In 6, part 1, a projectile is projected from a point on the horizontal plane with an initial velocity of 70 I and 140 J. Right, so find the magnitude and direction of its velocity after 5 seconds. So this is very similar to question 3, where we had to do the same thing after 10 seconds. So this should be just the same calculations. Okay, so question 6, part 1. Okay, so this is question 6. Part 1, and it's fired off at 70 I plus 140 J, again, meters per second. Okay, so our question here is, I always like to visualize what's happening. So the particle fires up at 140 and has a horizontal velocity of 70. And obviously this is going to make it go in a projectile like so. Okay, so our question is after 5 seconds, right? So here, obviously, t here is equal to 0 because that's the beginning. So after 5 seconds, I'm just going to take a guess that it's here. I don't know that. So after 5 seconds, its horizontal velocity is going to be exactly the same. It's still going to be 70. But this velocity here will be something different. We don't know what that is. We'd like to find that out. So the velocity in the y at t equal to 5, that's what I want to find. Okay, so basically if you fire something up at 105 meters per second after 10 seconds, what would its velocity be if gravity is pulling it down? Acceleration due to gravity is minus 9.8. So u, v, a, s, and t. So these are y, y, will go equal, and equal. Right, so the initial velocity is 140. Final velocity is actually what we're looking for. The acceleration is minus 9.8. The distance up, don't care about. I know the time, it's going to take 5 seconds to get up there. So looking at that, I have u, v, a, and t. So that means I would probably use v equals u plus at is the equation of motion that I choose. So now putting those in, I get v, what I'm looking for, equals 140 minus 9.8 multiplied by 5. Okay, so that means that v is actually equal to 100 and oh yes. So this is 140 that, so it's 104, so 140 minus 9.8 times 5 is 47.5. Yeah, 47.5. So 140 minus the 47.5 is, so that means the velocity after 5 seconds vertically would be 92.5 meters per second. So this velocity here should be 92.5 going straight up and 70 going that way. So that means now that I have those two, I should be able to figure out the direction and the angle and the magnitude of that. So I'll draw that over here. So that is one answer. Well, it's not, it's part of the answer, it's on the way. So I have a situation where I have 70 meters per second traveling that way, and it's traveling up at 92.5 meters per second. That means it's traveling this way at some angle. It's not a very good triangle because this side should be longer. So we know this angle would have to be greater than 45 degrees. So if that's the case, then we just say, yeah, the tan of theta, which is of course the opposite over the adjacent, is equal to the opposite, which is 92.5 divided by 70. So that means that theta equals the tan inverse of 92.5 divided by 70. So just put it in the calculator. So tan inverse of 92.5 divided by 70 gives me an angle of 52. 52.88, so 52.9, we'll just say. Sorry, 52.9 degrees. Okay, and we did say that number had to be greater than 45, which does make sense. It is greater than 45. So now we know the direction, but we need to know the magnitude. So that's one of the answers. So the magnitude, obviously this is actually just a right angled triangle. It's got one, so we can use Pythagoras to get this out, the hypotenuse. So the hypotenuse squared equals this squared plus this squared. So in other words, we'll just call it V is equal to 70 squared plus 92.5 squared. We got the square root of all that. So that's 70 squared plus 92.5 squared. So that means that V equals 13456 equals the square root of that. So I think that looks like it's 116 meters per second. That's the actual, that is the magnitude. Well, yeah, that's the magnitude velocity. So that answers part 1.